Hello, everyone. Good morning, afternoon, evening. Dear authors and invited guests, welcome to Technical Session 6B. Myself, Ashutosh Goel, and this session will be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you all to the 10th International Conference on ICT for Sustainable Development, ICT4SD 2025, Goa, India. The 10th edition of the conference is being organized in a hybrid mode. The physical event is being held today in Goa, India, and the virtual event is being held through Zoom from 17 to 19 July 2025. I hope you will enjoy the knowledgeable and interactive sessions throughout the day. In this session, we have 10 presentations, and each presenter will be given 10 minutes for the presentation and 2 minutes for question and answers. On 9 minutes, I will raise a gentle reminder. There is another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in the chat box. Just before we start the session, I would like to introduce you all to the chair for the session, Dr. Garima Sharma. Dr. Garima Sharma holds a PhD in Industrial Engineering and is currently serving as an assistant professor at Maharaja Agrasen Institute of Technology, New Delhi. I would now like to invite Dr. Garima Sharma to share a few words of encouragement with our attendees as we begin this session.
Thank you for that kind introduction. Am I audible? Am I audible to you? Yes, good afternoon to all participants. It's a pleasure to chair this session. We have lineup of 10 insightful presentation today, and I look forward to vibrant discussions. I Let's begin our session and invite our first speaker to present.
Good afternoon, everyone.
Yeah, just a second.
Sorry.
I would like to call Sir Samar Chikne to present his paper on the title AI-powered smart glasses for visually impaired individuals.
Good afternoon, ladies and gentlemen. Today I'm here representing my college and my team, which have made this wonderful project, and I'm here to share all the insights about it. So, as you all know, AI is a big step in this industry, and helping out blind people is a big cause. Our problem statement to deal with this was that millions of people in the world are suffering from blindness. It may be due to birth or due to some accident that happened in their lifetime. We proposed a system that uses AI integrated smart glasses to help people detect object and gain the distance from the object so that it may help their life become easier and much more movable. Let us get to understand our objectives first. Our objectives to build this project was to help blind people move easily in their life without any help from others and without relying on the society. We used mostly ESP CAM models and YOLO models to train our ML system. The hardware components which were used are ESP32 and ESP32 CAM model. These are high power microcontrollers which can handle up to any powerful model from our ML system. We created our ML model on our own while training our own databases and helping the model gain knowledge from our day-to-day lives. We use ultrasonic sensors to gain the distance using the speed of sound formula and calculating the distance so that the user can find the distance from the objects. We use batteries like LiPo batteries or lithium-ion batteries for higher usage and easy recharging. We tried to make this project as sustainable and as cheap as possible so that every common man can gain access to this. Our project, for us, it cost less than 1,000 rupees, which I think is pretty cheap for such a good system. The software we use was YOLO V5. It is a AI model used for object recognition. It has its own data set, and we even trained our own using our day-to-day lives. The object detection process happens on a local server-based system. We used our laptop to gain the images from our ESP32 CAN and process them and label them through our laptops and sending the feedback back to the users. We can also make this process everything cloud-based so that there is less hardware involved and everyone can easily access it. The audio feedback and text to speech we used were TTS by Google eSpeech. It helps the user understand that what type of object is in front of them. We used more than 1,000 images and 1,000 objects to build this database, and we think that this is a fulfilling database itself. The workflow of a system was that the ESP cams and ultrasonic sensors take inputs from the surroundings. They send it to a local server using Wi-Fi. The server processes it and sends it back to the ESP32 so that it can notify the user about the objects. We also added voice commands like start, stop, and calibrate to make sure that everything is working perfectly and there is no malfunction in the system. This is the block diagram and how it works. The visual feed is sent to the ESP32 and it moves to a local dark database. And then everything processed and the feedback is sent back to the user. We made sure that this process is the latency is very low and the objects can be detected easily and the accuracy is perfect. The results we gained from this were that the ESP32 CAM can handle up to a 4 GB model on its own without adding any more accelerators. So we tried to maximize its potential, and the latency we got was less than 200 ms. So that means that if a person sees an object in less than 200 milliseconds, he will get back a response on what that object is and how far it is. I think that's pretty good considering the low cost budget we were working on. And the ultrasonic sensors were pretty quick too. And the overall system, considering the processing power of the laptop too, everything happened less than a second. The feedback we got was great, and most of there was no malfunction in the systems. Our conclusion regarding this project is that this is a really good project, and we can make improvements by using better microelectronics like STM32s or better microcontrollers by creating our own using various electronics by importing them from other countries or making them own on India. We could also integrate GPS so that the family of the user can get to know his or her location using that GPS system. We can also create more enhanced AI models so that we can get better understanding of the object and it will be more accurate and not put the user in any kinds of harm. We can also use flexible electronics because these glasses can be a bit heavy for some people, for small children or women. So we are trying to minimize the electronics we are using on it and making a pretty portable system. These are the references we used, and I would like you all to read them through because these helped us a lot during our process. Thank you.
Yeah, this is an impactful and thoughtful project. My question is, what motivated you to work on this particular project?
I'm like in our college, there are many blind people we see around, and like my best friend is blind himself. So I created this to help him go around his day-to-day life more easily. But he uses like a smart cane which uses ultrasonic sensors and tells the object like object distance, but it can't recognize the object. So
Very.
there are sometimes it malfunctions. So we created this keeping him in mind.
So, how accurate is your object detection system in real world scenarios?
See, for the system like model we used, it was a 4 GB model, and we were getting an accuracy of 95%,
Oh,
or like the minimum it went to 92%. But we can like decrease the load on the ESP32, and it will be much greater.
okay, great, great. Thank you, thank you.
Thank
Over
you.
to you.
Thank you for the presentation. Moving on to the next one. We have Sparsh Kumar with the paper title AI-driven hemodynamic profiling integrating computational fluid dynamics and machine learning for cardiovascular health monitoring. Mr. Sparsh, are you here?
Yes, hello, good afternoon, everyone.
Yeah. Good afternoon, sir. You
So,
may start with your presentation now.
yeah, so I will be presenting now my PPT. Wait. Is my screen visible?
Yes, it's visible.
So today I will be presenting on the topic AI-driven hemodynamic profiling, integrating CFD, fluid dynamics, and machine learning for cardiovascular health monitoring. So the main introduction for this is, so the main idea is like, so in today's world, there are lots of heart attack cases. The person who are having very less is also like around 20 or 30s also are getting these heart attack. So to minimize this and reducing the cost of the various tests like 2D echo, TDM or ECG, we have designed such an algorithm that it will help the normal people also to afford it, can test their data with the help of simulation, which means that CFD. So the main introduction is like that to reduce the cost and to prevent the diseases caused due to the cardiovascular infections. We can use the integration of the CFD and machine learning to analyze the hemodynamic data using a 3D model of the human aorta. So we have divided our project into the two steps. So first of all, we have designed the simulation. So I have mentioned some of the simulation steps. Like for the geometry, we have imported our geometry from the vascular model database, which is managed by the SimVascular. And for the meshing, we have used high resolution pulsatile flow and compliant walls, which is just similar to our natural human heart. For the solver equation, we have used the Navier-Stokes equations because we want to make it like the to be considered as the real life example. So we have to apply some physics laws. So Navier-Stokes equations are the best possible equation that we can use. The tool used for our simulation steps is the SimVascular, and the output we got is VTK files. So the VTK files, there are several VTK files in that, like velocity, pressure, and WSS. So these all are the different types of VTK files which we can import in the post-processing tools, which is ParaView. So the ParaView is the famous open source visualization tool. In that we can import several formats of files, and we can just apply some of the parameters and visualize our data. So for our requirement, we have considered pressure field for aortic pressure variations, velocity field for streamlines and color maps, wall shear stress zones for high and low shear stress regions, slice view for cross-sectional flow insights, wrap filter for 3D velocity enhancement. And as I have mentioned, our geometry considered as are having 23,777 data points. So these points are nothing but the coordinates of our heart. For example, I have imported a one part of our heart and in the SimVascular. So the SimVascular and divided it into the 23,000 points. So we are analyzing our complete data on that points only. And for ML features, we have developed a machine learning model. So for that, we have used the pressure, velocity, and wall shear stress as the main features. So we have considered some of the literature review and found that these two papers are the most similar ones. So the first paper is hemodynamic changes in aortic situations. So they have also analyzed the blood flow in mild, moderate, and severe aortic stenosis, and they have find some elevated wall shear stress and turbulent shear stress. And mentioned some of their research parameters like the uh, Pascal pressure in their geometry, which we have used for our project reference. Some skewed jet formation and flow separation were observed in their paper, which was increasing the stenosis severity, which helped us to identify the high wall shear stress regions. The second paper is wall shear stress and pressure patterns. So they developed patient-specific CFD models from CT angiography using a GPS-rated Navier-Stokes. So in that, we have used the complete CFD models, but they have also tried to integrate the CT angiography. To make it more compliant to our project, we have increased the data set from the CFD. Like we have imported several geometries in that and analyzed the data. And there also are aortic dilation altered WSS gradients, which affect the plaque formation and hemodynamic patterns. So in our project, we directly identify the plaque using the simulation. So these are the research gaps between them. Like they have used only CFD, but we have tried that CFD data in our ML model to find the exact region of the plaque formation so that the doctor can directly identify the region and perform their stent operation or any other precautionary acts according to the position of the plaque in the heart. So these are the some research gaps. And then the second paper, they use CT angiography for patient specific models, while our approach is simulated driven. Because simulated driven is more accurate, as because there are various open source simulation softwares like SimVascular, ComSol, which we can get through the iStem or directly from their website, which really have higher accuracy and provide the real time based data. So the main challenges that we have, the main challenges occurred are scalability, because the data set are very big and the simulation models requires around 24 to 30 hours for running. And also the data set should be accurate. So for that purpose, we have used some DGX from the NVIDIA, which are 400 GB RAM. So it requires high computational power. The motivation behind is to like, because of the higher rate of heart attack in the lower ages, so we just want to decrease it by providing such softwares and generating such softwares, so that it will also help the other people to reduce and to save their money from various tests, and it has also a very higher accuracy. So the problem statement is the project aims to develop a precise non-invasive approach using CFD and machine learning to identify higher wall shear stress regions, improving diagnosis and treatment planning. So our main objectives were develop a hybrid framework combining CFD and ML for non-invasive cardiovascular diagnosis, detect high wall shear stress regions in the aorta to identify potential RTL abnormalities, provide an accurate and cost-effective alternative to traditional diagnostic methods. So this is a complete methodology in which we have first acquired our data from the SimVascular database. We have generated the VTK files from it. We have then the simulation output, we have imported it into the ParaView module, in which we have performed various steps like pressure analysis, velocity visualization, wrap by vector, stream tracer, and WSS analysis. And from ParaView, we got a CSV dataset, which we call as an extraction layer. Now we have using this CSV dataset in our machine learning model, we have loaded the dataset, defined a threshold definition. After researching in the several papers, we came to know some of the Pascal values of the pressure, some of the velocity values inside our heart, and using that threshold values, we have trained our machine learning model. So for our training, we have used RF random forest classifier because it is based on our several decision trees. So our project requires very high accuracy. So we have performed our testing on various types of machine learning models and to deep learning. But the best one we came to know this is RF classifier. So using that, we have performed some of the EDA evaluations.
हाँ मनीष हाँ
तो मैं अभी आप सीट पे हो या आसपास की मतलब एग्जाम चलिए आसपास
नहीं कंप्यूटर लैब आज
कंप्यूटर लेके सर 4:30 बजे आप कंप्यूटर ले लो 4:30 मतलब 4:30 आसपास ठीक है सर मैं 4:30 बजे निकलूंगा आपके पास
So for EDA purpose, we have defined some of the statistics. Like for visualization and threshold values, we plotted a color map in which the whole artery of our heart is plotted, and we came to know the exact location of our plaque formation. For example, if there is a tube and there is a plaque formation at the end of the tube, so the EDA will help me to directly identify that position of the plaque. Like it will plot that end area, the affected area too, that is covered inside the plaque. So I've discussed with the results, like it will plot the stenosis points and will highlight the regions also. So the methodology is like dataset generation. As I have discussed, we have used a CFD, SimVascular and ParaView. And for the post-processing, we have used the ParaView. So in that, it requires the VTK files. So these are some of the images that I have attached. And now machine learning integration. So the graph which is shown here is nothing but the feature importance. Like our data set contains several features in that. So the most important features are pressure, velocity, and the double wall shear stress. So we have used these features. So the results are the simvascular simulations provided hemodynamic data for pressure and velocity variation. Paraview analysis identified critical regions with significant pressure drops using statistical functions. The flow visualization techniques are here that we used are stream tracer and slice functions, which showed flow trajectories and cross sectional characteristics. The wall shear stress analysis identified regions prone to high shear stress and atherosclerosis. The machine learning results are pressure threshold values and WSS threshold values are mentioned here. So for that threshold values, we have used the quantile concepts are of our statistics. It's like we have used some of the mathematics also here to calculate the threshold values also, because maybe the different there are several humans and each human have their own characteristic. Like some are having some diabetes or sugar, then they have some of the different flow in their heart. So every person can differ with their threshold values. So for that purpose, we have used the statistical model also to calculate the threshold values as per the human heart. So the key results are total higher wall shear stress detected are 1288 points, which is nothing but the 5.42% of the data sets, which is here signifies that, for example, if I have a heart containing 24,000 points, then after using this software, it will tell me like in your heart, 5.42% of your heart is contaminated with that plaque. Because in the 1 to 88 points, like with this 1 to 88 points, it will tell me like the coordinates of these points are having a cholesterol formation in my heart. So the doctor can directly analyze that points, which will help them to provide some of the cure. So the high WSS points correspond to areas prone to stenosis are arterial nerving. So this the figure 1.2 depicts our model accuracy, which is 99.67%, and the right side is the exact image of our simulation. For example, this complete drawing is the diagram of our artery, and in the end we can see that there is a black region. So that black region is nothing but the exact position of the stenosis, and the green points which are marked near the black regions are the affected areas. So that complete black part, which is nothing but the stenosis, are affecting that much area, which is nothing but the 1 to 77 points. So these all are our findings. The CFD simulation is provided accurate artery hemodynamic data. The statistical threshold models improved our ML prediction accuracy, and they predicted the exact high WSS location with the coordinate mapping. So these are all the points which are affected due to the plaque formation in that whole artery. So we can identify the pressure and wall shear stress magnitude, which is mentioned here. So we are not required with any extra tests. So the conclusion is our study successfully integrates CFD and machine learning to detect regions of high voice shear stress in the aorta, addressing the limitation of traditional diagnostic methods. The framework demonstrated high accuracy in identifying abnormal hemodynamic regions, providing a cost-effective, non-invasive approach to cardiovascular diagnosis and treatment. By analyzing pressure, velocity, and WSS distributions, the project offered valuable insights for optimizing clinical interventions. The feature scope can be focused on the integrating patient-specific data to enhance the model's precision and reliability. Exploring real-time monitoring through deep learning and automating the CFD-ML pipeline can further improve the framework. But in our case, for our data, the machine learning model is the best possible that we can use. So also the clinical trials and broader application in healthcare, such as early detection of arteriosclerosis and promising areas for expansion. So this is all my project and some of the references that are mentioned here that we have used in our research paper. So thank you.
Yeah, very good. This is an insightful and well structured presentation. My question is, why did you choose a random forest classifier over other machine learning methods?
Actually, ma'am, we have tried different machine learning models also, but on experimenting it on different types of machine learning model, the main motto is to find the exact position of the stenosis so that the doctor can identify the location and directly perform their stunt operation depending on the condition of the human. So the random forest is based on the several decision trees. So because of that concept of the machine learning model, it gives the highest accuracy because without accuracy we can't perform any medical clearance, because if there is any wrong results, for example, my software gives like the location of the stenosis provides the like My software will, if my software give the wrong position of the stenosis, then it will create a trouble for the doctor as well as the patient too. So for that purpose, we have performed several things. And in our case, the random forest is the best suited one for the higher accuracy.
Excellent, excellent. Wonderful project. Thank you. Over to you, Anisha.
Thank you for your presentation, sir. Moving on to the next presenter, I would like to call upon Ma'am Vanushi Pabalkar to present her paper on the title Application of Sentiment Analysis in Marketing. Do we have you here with us, ma'am? Do we have anyone else from the team with us? Since there's no response, we'll be moving forward with the next presenter. I'd like to call upon Sir Kumar Rahul to present his paper on the title Artificial Neural Network Applications in Social Media. Do we have you here with us, sir?
Hello.
Yes, sir, you're audible.
Yeah, I am here. Just a minute.
Okay, sir.
Yeah, my screen is visible to all of you.
Yes, sir.
Thank you. Good afternoon, everyone. Myself, Rahul, and I am here to give my presentation on the title ANN Application in Social Media with my colleague, Dr. Ramji Gupta, Dr. Neeraj, Dr. Surinder. Well, in my presentation, I will go through quickly the abstract introduction, functioning of ANN, LR, conclusion, future work, and the reference as well. ANN having a very important role in social media, including Facebook, Instagram, Twitter, and all that, and which is going to assist in presenting the content recommendation, what type of content it is there, analyzing the user engagement in different activities, detecting the sentiment, and automating the moderation process. Basically, it is going to moderate as well. The ANN basically enhances the personalization of a user, and it improves the advertising strategy, and it detects the harmful content as well, because that is going to play with the data, and it is going to engage with the sentiment, and it is going to analyze the data, and it is going to give the insight to the user basically, which ensures a seamless and engaging the user experience. ANN in social media, that is going to highlight the impact on the user interaction, how they're going to interact with each other, the content curation, and the platform security as well. This review concepts of ANNs in social media, which key advancement, challenges, and open issues are there, which are related to the data variations and evaluation criteria in social media. Additionally, a structured framework is proposed for the future studies focused on leveraging ANN to gain the social media insight. If we go through the introduction, ANN are simply artificial machine which takes the inspiration from biological neurons and learn to perform the various jobs by being subjected to various examples and data sets. The main idea behind ANN is to create a system that generates the identifying the patterns and characteristics which are hidden there from the data that has been passed through the different level, and it is being programmed with an understanding of the data sets which is being given to the model basically. In this picture, we can understand the basic functioning of ANN. There, the different input right from X1 to Xn, which is given to the different weights are associated with the different input symbol here, like X1, W1. It is going to summarize the summation of X1, W1 plus X2, W2 till Xn, Wm. And then it is going to define the objective activation function basically, and it is going to give the output. So output is going to be represented as a Y, so that will be the neuron output. If you compare with the biological neurons, we'll have an input, then the connection weight associated with the each input symbol given to the system, then that is the hidden layer basically, and then summation, and then activation function. So this is the basic working of ANN. Step-by-step processing of data using ANN, which we have proposed here, that is the obtain the raw input data, then clean and pre-process the data, then split the input data into train set and test the sets, then initialize the neural networks, then shuffle your trained data sets, then train the neural networks, convergence of neural networks. If it is no, again you have to go and shuffle and train the data sets which we have got it in the order, and then train the neural. If it is going to pass, that is the convergence of the neural networks achieves yes. If it is yes, then it will evaluate the model, and then it will perform using the test data sets which we have selected in initially, and then it will stop. So this is the process of data using ANN basically. This picture that gives the uses of ANNs is the topic is ANN in social media. So these are the different uses of ANN is given here, and that can be understood through this pictorial representation here. For creating the virtual assistant to the users, to create AI-enabled chatbot, it is there. To build the AI-powered customer service engines, to analyze opinions or behavior of the people, those who are working towards the certain topics, that includes your sentiment analysis, for predictive analysis, for image recognition purposes, for processing of NL, for digital marketing purposes, and for creative, the virtual. So these are the different uses of ANN in social media that are there basically. During this, we have gone through certain literatures and different works has been done by the different author in past. We have compiled here few of them, which are very important in terms of the social media applications. So in 2017, T.C. Wong interpreted the comments on social media sites generated by users with the help of artificial neural network. In 2017, Heng and his friends, they have worked with the RNN for discovering the topic of short text, large amount of text, images, and other type of data which are being used. In 2018, D and his friends works with the DNN, and they utilized for the recognizing the personality through the textual content available on the social media. In 2018, the authors expressed the tweet play, tweet data basically. So they have worked with the Twitter data, which are important role in sentiment analysis, how people are reacting, acting, and responding on the Twitter. In 2019, the different authors have predicted 86.67% accuracy of addiction of the social media, which is given here. And we have already given the references. In 2019, authors detect the societal ideation in social media, which are quite common nowadays, that has been caught to work with the deep learning. Then also the spam detection through CNN, and then also performed the emotions for the bogus statistics in the social media industry, fake information, nature-based and inspired approach for the automatically classifying cyberbullying occurring in various social media. Then in 2021, Mahajan and his colleagues, they have worked to find the correlation between social media and crime. So if you go through the entire concept of this literature review that various authors have worked, right from the societal, the behavior and the predictions of addiction of social media, and the sentiment analysis, the bogus statistics, the effect of cyberbullying and all that. So none of the area has not been, untouched. So almost every area of the impact of social media, of impact by ANN has been brought by in notice by various authors here. So ANN are simply an attempt to make a computer model of the human brain, and social media platforms are being used by the millions, or can say billions of people across the globe every second of every hours. This lead to the generation of the effect of it is a lot of data is being generated. So generation of huge amount of data which are being generated by the different way on social media that need to be stored and processed properly for the better and effective utilizations for the human being. So this data is highly valuable and beneficial to the business as well as government and organization, and it helps them to better understand the customer and their behaviors, like, dislike, needs, and demands in for futures. If you go through the future works that is there, and people can carry forwards the valuable insights and the knowledge which can receive from the data which are being available in the social media, the impact of uses of ANN, what is there in the different way that can be useful for the betterment of the society. So the insight gained from correlation between society, ideation, depression, cyberbullying, crimes, etc., which social media provides the useful information and insight for the decision-making authorities in order to improve the prevalent conditions. Thank you. These are the reference which we have used for the paper.
Thank you. This is well structured and informative presentation. My question is, you mentioned a structured framework for future work. Could you briefly elaborate on the key components of that framework?
Yeah, ma'am, that can be there to know well in advance, like the local police, if they have such kind of data that these are the people and who has been activity has been watched in certain cases, so the people may alert well in advance before the incident happen. So those data can be shared that these are the probable people, or these are the probable link of social media, and their activities are suspicious.
Right.
So that can be shared well in advance to the society and the authority so that they can take care of them.
Right. Okay, thank you. Over to you, Ashutosh.
Thank you, ma'am.
Thank you, ma'am. Thank you, sir. Now moving on to the next presenter. Now I would like to call upon Sir Tejas to present his paper on the title Classification of Brain and Lungs Images Using Deep Learning Models and Low Complexity Algorithm. Do we have you here with us, sir?
Hi, Ashutosh.
Yes, sir.
Am I audible?
Yes, sir, you're audible.
Okay.
You may present your screen, sir.
Yes. Is the screen visible?
No, sir.
Can you let me know if the screen is visible right now?
Yes, sir, the screen is visible.
Yes. Good afternoon, everyone. I am Tejas N from KLA Technological University, Hubli, and I will be presenting this. I will be presenting my research based on the title Classification of Brain and Lungs Images Using Deep Learning Models and Low Complexity Algorithm. So this is all I will be covering in my presentation. So starting with the introduction, medical image plays a vital role in diagnosing life-threatening diseases such as brain tumors and lung related issues, and modalities like MRI, CT scan provide detailed anatomical information, enabling these early disease detection and improving patients' outcomes. However, the complexity of the processing high-resolution medical images and extracting meaningful features for classification present significant challenges. We did some background study related to the models where neural networks have become foundational in medical image analysis, and architectures like VGG16 and EfficientNet are mostly used because VGG16 is known for its simplicity and effectiveness in extracting features, and EfficientNet balances depth, width, and resolution to achieve better performance with fewer parameters by using compound scaling. However, while deep learning models are powerful, they can be computationally expensive. So to address this, we are using PDBS model, a pixel division and block summing model. It is a low complexity algorithm that uses bit plane compression and blockwise feature extraction for image classification using nearest neighbor distance, which allows us for faster, efficient diagnosis with reduced processing overhead. So we have used three models in this project. One is VG16, EfficientNet, and PDBS. PDBS performs the image compression, block summation, and classifies using feature vector distances with minimal computational load. And each model was evaluated on its performance using training and testing accuracy across two datasets of brain tumor MRI images and lung CT scans. We had four major steps in this research. First is data collection and preprocessing. The data sets were sourced from Kaggle. Brain MRI images were classified into four categories: glioma, meningioma, pituitary tumor, and no tumor. And lung CT scan images were also classified into malignant, benign, and normal cases. And all these images were resized to 256 into 256 pixels and were normalized to a scale of 0 and 1. After that, in the second step, we had compression and feature extraction for the PDBS algorithm. We applied bitplane compression using modulus operation. Then each image was divided into 64 into 64 blocks after the resizing, and the sum of the pixel intensities in each block was used as feature vector. Then the next step was model training and classification. For VGG16 and EfficientNet, a standard supervised training was used, and for PDBS we used nearest neighbor classification by comparing features vectors using absolute difference. And finally, we had evaluation metrics where accuracy was computed based on the number of correct predictions out of total predictions across both data sets. So speaking about the results, as we can see in the tables, comparing the training accuracies and testing accuracies via all the three models, VG16 performed reasonably well, but showed signs of limited generalization. EfficientNet demonstrated very well performance and the capabilities. On the other hand, PDBS achieved the highest accuracy while using minimal computational resources with minimal signs of overfitting, making it ideal for real-time and low-power clinical applications. To conclude this, I would like to say that this demonstrates the potential of combining both deep learning models with low complexity algorithms for effective medical image classification. While EfficientNet achieved strong results, the proposed PDBS algorithm outperformed both VG16 and EfficientNet in terms of accuracy and efficiency. It's suitable for clinical applications, especially in environments with limited computing power. These are all the references which I used in my project. Thank you.
Thank you, Tejas, for presenting such a technically robust and clinically meaningful study. My question is, could you briefly explain how the PDBS algorithm improves upon traditional training methods?
Yeah, ma'am. The PDBS, which stands for pixel revision, block summation, uh, which has steps like image pre-processing, where all the images are resized to 256 into 256 pixels for consistency, and then these images are converted to grayscale if needed, and then followed up by the image compression, which uses uh, the modulus operations. Then uh, this compression reduces the redundancy while preserving the features. After that, we use block-wise feature extraction. The compressed image is divided into 64 into 64 pixel blocks, and then this creates a feature vector for each image. And then we have, after this feature vector, we use this for nearest neighbor classification, and it calculates the absolute difference. So uh, it makes a quite difference and between the other like other models and this.
Excellent, excellent. Over to you, Ashutosh.
Thank you, ma'am. Moving on to the next presenter. Now I would like to call upon Ma'am Sweetie Singhal to present her paper on the title Enhancing Healthcare Data Security, Integrating NLP, Deep Learning, and Blockchain for Privacy and Compliance. Do we have you here with us, ma'am?
Yeah. Good morning, sir.
Good morning. You can start presenting your screen.
Yeah, sure. Is it visible to all of you?
Yes, ma'am.
Okay. Good morning to all. I'm Spiti Singhal and I'm here to present my review paper on enhancing healthcare data security using integrated technologies like natural language processing, deep learning, and the blockchain. Mainly, this work focuses on ensuring patient privacy and regulatory compliances in modern healthcare environments where data security is growing concern. So, moving forward to the introduction part, the digital transformation of healthcare has brought remarkable innovations such as electronic health records and telemedicine. So, these advancements improve patient care and streamline operations. However, they also introduce new cybersecurity challenges like data breaching and all. So the more interconnected and digitized our system become, the more exposed they are to attack. With sensitive data flowing across multiple platforms, protecting patient privacy is more important than ever. So innovations like EHR and telemedicines improve care delivery, workflow efficiency, and research capability. And the new vulnerabilities of the current scenario is to digital system are more accessible, but also more exposed to cyber attack. So this demand for secure data protection and now more critical than ever. Now, as my topic suggests, I'm integrating three technologies over here. First one is NLP, that is used to identify the text. Second one is the deep learning and the blockchain technology. So artificial intelligence, particularly NLP and deep learning, here offers a powerful solution for this problem. NLP helps us process vast amount of unstructured data like patient note or feedback, etc. It identifies and secures sensitive data, supporting compliance with laws like HIPAA. Deep learning complements this by analyzing pattern and detecting anomalies. And we use both combined impact. NLP plus DL enable real-time threat mitigations. It strengthens security of healthcare system through intelligent and automated defense. Here is the literature review where multiple models are used to implement this security. Our review begins with an evaluation of model like CNN and BILSTM and Distilbert and Robert 2 algorithm. A hybrid approach combining these architectures offers enhanced threat detection by understanding both local and global data context. A major concern highlighted is insider threat, which are often difficult to detect using traditional methods like machine learning techniques offer better precision in identifying such complex attacks. Further study shows the importance of addressing imbalanced threat data using techniques like augmentation and undersampling. Another trend is using social media like Twitter for early cyber threat detection, predicting vulnerabilities days before they are publicly known. Lastly, integrating blockchain and deep learning models such as GSO and DPCNN with Ethereum demonstrate the significant promise in securing sensitive medical images, especially in intelligent healthcare system. Next one is the key data privacy challenges in healthcare NLP. So there are several challenges in applying NLP security. First, data privacy concern arise due to the sensitive nature of healthcare data. The second one is the data anonymization dilemma. Over anonymization may remove vital clinical context affecting medical relevance. Under anonymization risk re-identification defeating the purpose of privacy preservation. And the third one is the model privacy risk that NLP model may memorize and leak sensitive data seen during training. As we all know, like there are chat GPT, they remember all of the information we are searching over there. And they leak that data in future in any website or any other apps. So this exposed patient information during model interference, posing a direct threat to the confidentiality. Next challenge is model integrity threat. That NLP model are vulnerable to adversarial attack and bias. A flawed and biased prediction can negatively impact patient treatment and the outcomes. The fifth challenge is to system integration complexity. That incorporate NLP into legacy system is challenging under new privacy law. These issues included cross-border data transfer, data fragmentation, ensuring compliance across platform and secure interoperability. So here's the conclusion where we inbuilt all the three approaches. NLP role as a privacy enabler here. It supports data anonymization and data encryption to protect personally identifiable information. It ensures patient privacy and trust in data handling. Next one is to understand unstructured data. NLP techniques like named entity recognition and sentiment analysis enhance interpretation of clinical notes and patient feedback. It also enables holistic healthcare insights. And the regulatory compliances, it ensures adherence to standards like HIPAA and GDPR. It supports periodic audits and automated regulatory checks. And the final one is the unified architecture. It integrates deep learning and NLP, both for the secure data management, scalable system design, reliable and compliant operations. Future trends in NLP for secure healthcare is as follows. The first one is to decentralize and secure collaboration. Decentralization will allow institutions to train model collaboratively without sharing raw data. Explainable AI, it is essential for the building trust among healthcare professionals. It continuous monitoring through wearable and health apps will enable real-time detection of patient issues. Lastly, combining NLP with blockchain will offer tamper-proof, traceable health records critical for the secure and future-ready healthcare ecosystem. And here are the references which I have used for my review paper. Thank you.
Thank you. This is an impactful and thoughtful presentation. My question is, have you tested this framework on actual clinical data set, or is it still theoretical?
No, ma'am. Actually, I have just reviewed all these. I still have not implemented any of these technologies yet.
Okay. Okay, thank you. Over to you, Ashutosh.
Thank you, ma'am. Moving on to the next presenter. Now I'd like to call upon Ma'am Madhuri Badole to present her paper on the title Intelligent Brain Tumor Detection Using Machine Learning Models. Do we have you here with us, ma'am?
Yes, yes. Thank you, sir.
Okay.
Thank you, sir. Thank you, ma'am. Good afternoon, everyone. So, as this project has been a team effort, so I would like to request my student Rohit to please continue with the presentation. Rohit, over to you, Rohit.
Hello. Good afternoon.
Yeah.
Hello. Yeah. So can I begin?
Yes, Rohit.
Hello. Yeah. So good afternoon, one and all present here. Here, Rohit Rathod, along with my teammates Harsh, Pawan, and Devanshu, with our guide Professor Madhuri Badole ma'am at Pimpri College of Engineering and Research. Here, I am honored to present our paper on intelligent brain tumor detection machine learning models. So here, firstly, here is the outline of our presentation, which consists of introduction, literature survey, problem statement, objectives, proposed system, methodology, and conclusion. So first of all, begin with our introduction. So introduction is in the brain tumor detection. It is one of the most critical tasks in the medical field. So our approach is evaluationary and which makes us optimization of algorithms inspired by the natural processes. To improve the brain tumor detection, we have used several algorithms to identify and for the correct predictions. So here I have used multiple literature surveys consisting of limitations and methodologies which have been defined in the table. Like there were many limitations which are identified by our team. Is there were high computational costs for the for the model, or there were lack of data sets, and due to the overfitting of the model was not predicting the correct prediction, and it's showing the false results. Then let's get moved to the problem statement. In the problem statement, the core problem which we need to address is to adapt an highly accurate system that can efficiently detect the brain tumor detection from the MR images. So we aim to the to minimize the false positives and a false negative. Then adapt the model to with various data sets, and then we are continuously improving on its performance and evolutionary techniques. So the objectives of the model was to design a system using an evolutionary algorithms for the brain tumor detection, to improve the accuracy using the optimized model parameters, and they implement a system that is scalable, efficient, and clinically valuable. So here is the proposed system which is shown in the model. Which up till now various models were built, and the proposed system was used by this model was given below, like data collection by gathering multiple MRI images, and then the data processing which consisting of grayscale images, normalization, and the augmentation of data, and then the feature extraction, in which this feature extraction it is consisting of the like extracting of grayscale images and co-occurrence of the matrix like GLCM and local binary patterns. Then it is get segmented the MRI images into the various tumor regions, and then it is get classified regarding the tumor regions and its types, which are basically it is classified into the four types. And once the tumor is like detected, so the evaluation part which comes, which shows the positive or negative results. And here it is a graphical representation of our model, which consisting of the overall working of a model, in which is start by collecting MRI images, then the data is get pre-processed, and once the data is pre-processed, it get split into the data set of train and test. Once the model is trained, and after adjusting the parameters, it evaluate the results and shows the positive and negative results. Once we achieve the accuracy, it will directly shown up the results. And what makes our model different? So here is a methodology. What our model is defined like the first common steps, which are consisting of data collection and pre-processing, and then the one of the most used model architecture we have used in CNN. The reason behind using CNN was having a greater accuracy as compared to other algorithms like random forest. Basically, random forest is most probably used in structured data formats. So, and then the training phase, and one of the most important in our model is like it is a self-learning model for like in brain tumor detection. There are minute brain tumor regions which are not detected by a human eye, or like by our model. So in that case, our model might be showing us a negative results to make them correct and to identify it as a correct result. So we can retrain our model by uploading that corrected images of the MRI images, and telling by the result, which is actually it is like positive or negative. And for that, we have used the reinforcement learning. For the correct prediction, we have ordered 10 points, and for incorrect prediction, we have negative 5 points. In which after the deployment of self-learning model, like we can identify and achieve the accuracy of 97%. We have achieved more than 97% by using other models, but due to which the model was becoming overfitting, and due to which it's showing us the wrong predictions. So the model refinement, up till now we have used like self-learning AI, and it is important for handling the uncertain cases, and like some cases which are not being identified by the model, or which can also useful for the assessment of the doctors for the better treatment and early diagnosis. And since basically brain tumor is classified in four types, so we are currently working on is the classification of four types in the advanced format of locating an exact particular area of the region. And the implementation and results we have shown in the PPT as of the sensitivity around the accuracy is almost 96% we have achieved till now. And once the after implementation of self-learning, the accuracy again increased by the 97%. And the clinical benefits which have been shown, like it most probably use 2 or 3 seconds more for the faster detection, and it has reduced the false positive reports by 40%, and due to which it has enhanced the brain tumor detection model. So in the next PPT, I will be showing some results of our model which the working. So here, once we have uploaded the image of the negative tumor detected, so it has directly shown up the negative result when the tumor is detected, and like here is positive. Sorry for that. And yeah, here is another image which shown up the small tumor region which is presented in the middle of the brain. So for that, we have used the self-learning to re-upload the image to identify it as a correct. And here it is a clear image of brain where no tumor is detected, and it can be clearly visible by our eye also, like it is a negative result, so it is already detected and no tumor. The requirement analysis of our model was like a high quality of a labeled MR image, which we have used the dataset from the Kaggle for the high quality. And to improve the performance, hardware performance, we have used the GPU and software for the Jupyter notebooks for the training of the model. Here we have used the 4 GB of RAM and the hardware requirements, which and the Python, which is used for the programming of the model and training of the model. And the libraries which are most probably used are PyTorch, scikit-learn, and OpenCV. And for the GPU support, CUDA is most probably used. And here the conclusion and the future scope. In the conclusion, like the brain tumor, we have achieved the highest accuracy up till now for our model, and which provide enhancing generalization across the patient population, integrating multiple data modalities like CT scan and MRIs, and improving the model interpretability and clinical trust. And here we have used the references for our model and publishing the paper.
Great. This is well articulated and meaningful presentation. My question is, could you elaborate on why you choose random forest over other classification methods like SVM or deep neural networks?
Yeah, ma'am. Basically, ma'am, we have used the CNN over the random forest and SUM. The reason behind it for this using of CNN, by using random forest, ma'am, we have not achieved as much, like we have achieved only 95% of accuracy. And since random forest is most probably used for the structured data, for the statistical representation of data and for the tabular structure, and our project is totally based on image segmentation. That's the reason. We have used SVM to identify, and we have achieved almost around 98 and 99% of accuracy. But the model was overfitting, and due to it is showing negative results, like incorrect results.
Thank you.
Thank you, ma'am.
Over to you, Ashutosh.
Thank you, ma'am. Moving on to the next presenter, I would like to call upon Ma'am Chinmay Ambarish Parvikar to present her paper on the title Optimizing Hybrid Solar Wind Systems with differential evolution for energy and stability. Do we have you with us, ma'am?
Yes, I'm here.
Okay.
I'll just start presenting the people. Um, can you see my slides?
Yes, ma'am. Your screen is visible.
All right. So I'm Chinmay Ambarish Parvikar, and I'm a bachelor student in KIT Bhubaneswar, India. So I'm here to present my paper on optimizing hybrid solar wind systems with differential evolution for energy and stability. I did this project with one of my co-authors, Shrutil Bhushan, and my guide, Preeti Parvikar. So as we move toward decarbonization, more than 1,000 gigawatts of solar and wind energy systems have been installed globally in 2022. Hybrid systems, that are those combining both solar and wind energy systems, are a reliable source of energy. But the problem with them is that the output that they provide is unstable and it often fluctuates a lot. So a key challenge here is that how do we get most energy while also keeping the output stable? So we reviewed a lot of papers, and many past studies have used optimization algorithms like NSGA2, genetic algorithm, and PSO. Although they work, they are complex, slow, and computationally intensive. There's another sector of these studies that focuses either on energy output or just stability, but not on both. So there's a clear gap when it comes to optimizing both the factors for small hybrid systems. So the gap that we're addressing today is that we need a simple, fast method that works in real world conditions and can optimize both energy and stability together. So differential evolution algorithm fits perfectly here as it handles complex nonlinear problems and is computationally light. We modeled a system that consists of 10 meter square solar panel and 3 2 kilowatt wind turbines. We varied the two parameters, that was solar panel tilt angle, which was from 0 to 90 degrees, and the space between the turbines, which was varying from 5 to 50 meters. Our objective here was to maximize the energy while minimizing the hourly fluctuation. So we used real 24-hour weather data to simulate realistic conditions. First, we tested a baseline model which had the solar angle tilt as 30 degrees and the spacing as 10 meters. Then we ran it through the differential evolution algorithm, which optimized it and gave us a tilt of approximately 15.23 degrees and a spacing of approximately 35.67 meters. The best part here was that the optimization had ran in seconds and it was reproducible with minimal resources. Now, how does this algorithm work with our objective function? It starts with random solutions and then evolves them using mutation, crossover, and selection. Our objective function tries to maximize the total energy while penalizing the instability, bringing us to the formula that F equals the total energy minus 0.1 multiplied by the stability penalty. So here is the full workflow. So we define the problem and set the range for the tilt and spacing. Then we move on to collecting and pre-processing the 24-hour weather data. Then we model the energy output using the physics. Then we run it through the differential evolution algorithm to optimize it using the custom objective function that we just saw in the previous slide. And finally, we compare the baseline versus the optimized results. So here are the results. This graph shows the baseline versus the optimized results. So we found out that the energy output had increased by 12.7%, and the power fluctuation penalty had decreased by 13.4%. So this means smoother energy supply was provided with fewer sudden spikes or dips. So the optimal setup was a tilt of approximately 15.23 degrees and the spacing of approximately 35.67 meters. Which brings us to a conclusion, which was that differential evolution algorithm is a fast and effective tool for optimizing hybrid energy systems. It helps us get both higher energy and smoother delivery of power, which is great for smart grids and microgrids. And most importantly, it bridges the gap between focusing on just energy or just stability. So the next steps that we can include are adding a battery storage for inverters to the system, running it for longer periods or scaling it to larger systems, and combining it with machine learning and IoT for smarter control. Here are the references that we studied. Thank you.
Thank you. Thank you for your technically rich and well structured presentation. My question is why was differential evaluation chosen over other optimization algorithms?
As I said in my literature review, those other algorithms were studied and they were only reviewed. They were not tested by me, but they were slow and computationally intensive, which we didn't really want. Also, I had a review paper on this before where I had proposed the idea of microgrids and hybrid systems as a solution. And up about recently, I got to know about this algorithm. That this algorithm could also be used for this. So that's why I chose.
Okay, excellent. Over to you, Ashutosh. Thank you.
Thank you, ma'am. Now moving on to the next presenter. Now I would like to call upon Sarah Mogem to present his paper on the title Physics Informed Neural Networks and Simulated Cardiac Data for Arrhythmia Classification. Do we have you here with us, sir?
Hello, Ashutosh. Am I audible?
Yes, sir, you're audible.
Okay. Just give me a moment so that I can present my screen.
Sure, sir.
So is my screen visible?
Yes, sir.
Okay. So respected reviewers and everybody present here, good evening. I am Amok RM and I'm going to present the research done on the basis of physics informed neural networks and simulated cardiac data for arrhythmia classification. And my co-authors are Sir Satyajan Chikerur and Sir Prashant Kumar. Moving on. So in the title itself, it is stated that physics informed neural networks and simulated cardiac data is used for arrhythmia classification. Before moving on, one second. Yeah. Before moving on, let me clear some prerequisite knowledge is required here. That is, what is cardiac arrhythmias? Cardiac arrhythmia is a well-known cardiac disease or a syndrome which involves uneven beating of heart. Or, for example, the people here can understand the lub-dub of heart, the heartbeat. When there is an irregularity in the beating of heart, that is called as arrhythmias. And for every project there are whats and whys. So let me first explain what and then we'll move on to why. So what is this research? So this research is, in this we are going to simulate the cardiac arrhythmias data in vivo, and then we are going to apply several machine learning algorithms so that we can prerequisitely we can identify if a person is going to get arrhythmias or not. And moving on to whys. Why? Because one of the main vision and mission of this research is to reduce the mortality due to cardiac arrhythmias. After coronary artery disease, this is the disease which is taking lots of lives throughout the planet. And major reason why people are people are not able to survive this disease is because the correct infrastructure is not available for precise determination of this disease. So for the why is the motivation is because of the same thing, and also the clinical expenses will be very high for the determination of this disease. That's why we chose to do the research on this topic. Moving further, so what we wanted to do is we simulated the ECG dataset and used several different models such as CNN, LSTM, PINN for arrhythmia classification. And after that, we determine which model is performing better so that we can use that for the higher accuracy and basically to reduce the mortality. So moving further, we had gone through several papers for identifying the methods used by them and also identifying the gaps. So few of the papers are mentioned here, which we took major inspiration, and also we did a trade-off with those papers so that we can enhance our research. So the first one was ECG arrhythmia classification using logical model trees and so on. The papers are visible on the screen, and the gaps are also. And the major gaps which we encountered were in the in vivo, that is on machine determination using any model. The problem was happening in the variation. For example, human body is a set of a new machine toolkit, for example. So every time we think there is a pattern, it changes its own pattern. So variation and variance is based for all the unsupervised learning models. So we try to concentrate more on the supervised learning models, for example, CNN and LSTM, and also PINN, for example. Moving further, so what we need to know before we understanding this research. So ECG, everybody knows what ECG is. So diving down into ECG, there are something called as P waves, QRS complex, T wave, several T1 to T19 waves, which happen to come in the ECG sets. So we are going to use those things to determine whether a person is having arrhythmias or not, and also to classify into which category of arrhythmias a person has, as because there are n number of categories of arrhythmias based on their characteristics. But the major types of arrhythmias are mentioned here, which are responsible for death toll. So, ventricular tachycardia, fibrillation, sinus bradycardia, atrial fibrillation, atrial flutter, and tachycardia of supraventricular, and also atrioventricular blocks. These these are the major groups which regulate the mortality. So that's why we concentrated on classifying into these subsets. Moving further, so for classifying it, we had to do the simulation. So we had a data set of 16,000 points, wherein we acquired the data and then did the path planning, segmentation, surface modeling, meshing, and after all we did something called as a finite element analysis, wherein each of the point of heart is considered as a finite element, and we use partial differential equations to solve those problems using an equation called as Fitz-Nagmo equation, where we'll be seeing about that in further month. So this is how the images are, and after segmentation the right hand side looks like this. After segmentation, so this is something called as a cardiac cycle. The lumped up thing is similar to diastole and systole. So the contraction and relaxation of the heart is represented here using these images. So as mentioned before, meshing. Why we do meshing is to capture or capture the 3D essence of the heart. We require meshing. After that, the result of the simulation came out to be something like this. The thing which you're seeing on the screen is are called as Purkinje fibers. These are mainly responsible for transfer of electrical signals into heart. So we calculated on the basis of minus 4 millivolts to 30 millivolts, so that there is a variation in the beating of the heart. It represents the relaxation and contraction of heart. So this is the proposed methodology of our system. So we take input from those voltage. The voltages are again in the several form of either Excel sheet or many images, wherein we have P, Q, T, heart rate, intervals, QRS, QT, segment waves, and T waves. And for that, we use a governing equation, that is Fudge-Nago equation, and we feed that into physics informed neural networks. And after that, we will estimate the output based upon the input. So the deep learning models which we used are these. One is CNN model, then LSTM models. Why we use CNN model? Because it is excellent in extraction of spatial features from images, that too. And that's why CNN model was preferred. And LSTM model also is considered because it uses sequential method for capturing of temporal dependencies. Next, moving on to physics informed neural network. So what physics informed neural network is actually combination of physics into neural networks. So as it can be seen here, we use partial differential equations to solve to use and solve the problems, and then use that equation on each of the data point to get the required loss or accuracy. So these were the results after performing, which in which physics informed neural networks led both
So
in the
gentle
test.
reminder that 9 minutes have been completed.
Okay, sure. PINN performed excellently when compared to other models, maybe because when we add physical constraints into a model, it becomes more like a real life thing rather than just taking images or just using temporal data for again pattern recognition. This physics informed neural networks involves physics, which means the things which are happening in the real life, the variations which are happening in the real life for into the training process, which ensures the predictions to follow the real human like and physiological behavior, which gives the interpretability very good. And the moving on to conclusion that our CNN and LSTM are accurate but limited in interpretability. But when we use physics physiological knowledge, the accuracy increases. Why? Because of again the variance and varietism. So the future scope, one future scope which is not mentioned here, which I'm going to tell is we there are again many aspects of arrhythmias wherein we consider only few aspects, as because this project is in just the preliminary stages. We would like to implement and take this into vast consideration so that there can be like very less number of mortality based on this disease. Thank you.
Thank you for a highly insightful and well structured presentation. My question is, can this model be adapted for wearable or mobile health monitoring systems in real time?
Yes, ma'am. The like now advent of AI, what is happening is we are trying and usage of GPUs has been integration of usage of GPUs and AI will eventually help in making a monetary device which are variable,
Okay,
and
great.
it will also provide a good insight for the neural network or the AI model which we are integrating, because it will be taking the real-time data and live data.
Okay, great, great.
Yeah,
Okay, over to you, Ashutosh.
thank you.
Thank you.
Thank you, ma'am. Now moving on to the next presenter. Now I would like to call upon Sir Sajal Nampalewar to present his paper titled Smart Financial Learning an intelligent agent with chatbot assistance. Do we have you here with us, sir?
Hi, good evening. Actually, I'm here on behalf of Sajjan Lampaliva. He was busy somewhere.
Okay, sir. You may present your screen.
Yeah. Is the screen visible?
Yes, sir. Your screen is visible.
Okay, so good evening, everyone. I'm Siddhant Sawant from NMIMS Navi Mumbai. I'll be presenting our work title Smart Financial Learning and Intelligent Agent with Chatbot Assistance. So basically, this research addresses the growing gap in financial literacy among youth and presents an AI-powered educational framework tailored to young learners. So a quick overview of the key segments that I'll be covering today. We'll begin with the introduction and problem statement, then literature review, framework design, implementation, evaluation results, and then conclusion followed by future work and scope. So the introduction. So in today's fast-paced financial world, most children and teenagers don't get structured financial education, which leads to poor money habits, over dependence on others like parents, and uninformed financial choices. Like the data shows, only 24% of Indians are financially literate, and we rank 73rd out of 144 countries in global financial education, which indicates a major gap over here. So our solution is basically an AI-powered platform that integrates intelligent agent for assessment and guidance, interactive tools like a stock market simulator, budget planner, and newsletters, and an AI agent that encourages critical thinking through reason-based quizzes and as well as feedback. So literature review. So our review spanned multiple domains: AI in finance, chatbots in education, reinforcement learning, and fintech tools. Each study offered value, but several gaps remained. For like the first one, Alex Zhu 2024 built a forecasting tool using Monte Carlo plus LSTM, but it wasn't scalable or designed for students. The next one explored GPT and BERT for financial decisions, but faced trust and bias issues. And similarly, the rest of them also had some gaps. So how we address these gaps is we used lightweight PEFT methods like LoRa and QLoRa to reduce computing methods. PEFT stands for parameter efficient fine tuning, which is basically a method to fine tune only a small part of a large model instead of updating the whole thing, which saves memory, computing power, as well as the training time of the model. So moving on to the framework design. So this is the core of our solution, basically a modular intelligent agent framework. So first, so there are four parts to it: the brain, perception, memory, and interactive delivery and feedback. So the quiz generation is followed by the content repository where all of the data is there, like the brain. Then moving on, there is the 100 billion model parameter 100 billion parameter model which generates the quizzes for each individual, which creates a diverse financial literacy questions based on the content repository, which is the knowledge base, and it covers all the types of difficulty and a vast topic coverage. Then the 7 billion parameter model is where the model attempts to solve or respond to each question, and it may produce partially or incorrect answers or maybe hallucinated. Then this learning module, the student part is where the students review the 7 billion parameter models outputs, which encourages their critical thinking ability and identification of possible errors. And then the 1 trillion model gives the correct answer, and that way the user is able to efficiently think about the answer as well as the problem, as well as the model gives a clear explanation, step by step reason based evaluation, so that it gets easier for the student to learn. So this multi-layered design promotes explainability and reflection. So moving on to the architecture of the app. So basically, first, the user can be a student as well as a teacher. Since financial literacy is not not restricted to any particular age group. Anyone can use it. Then for front end we have used for the dashboard for front end we have used React.js, and there have been four basic modules. First is the stock market simulator, where the user gets around 10 lakhs as a virtual money, and the user can trade or invest according to the chart or according to his learning and according to the resources that are there on the platform, as well as the assistance given by the chatbot. Then the budgeting and expense tracker is basically how you can just connect it through your Gmail, and then the user can track his or her expenses and manage goals. Newsletter one is the part where you get around new news, around 10 to 20 articles daily, which covers the entire global financial news for the student to keep him updated. Then the financial learning tools are basically resources that we have put on the platform to for the user to read and learn, and we have also attached some links to the YouTube videos so that the user can adapt to it. And then the chatbot, obviously, where the user is able to use the chatbot while he's learning or investing through the simulator. In the backend, we have used Flask plus MongoDB, and it integrates with external APIs like in the backend, OpenAI, and Llama 100 billion parameter, of course. And for the storing of the data, we have used MongoDB. And for the DeepSeek basically helps. What we have done is we have fine-tuned the DeepSeek Llama model on the dataset called Finance Instruct 500K, which we had found on Hugging Face, which is a domain-specific dataset, making it ideal for understanding financial terminology and queries better than the general purpose models. So we had used DeepSeek Llama R1 still distilled 8 billion parameter because the distilled 8 billion version of DeepSeek offers high performance at lower compute cost, which had allowed us to deploy it efficiently without needing huge GPU resources, even though we had spent quite a few dollars to build on it. Yeah, so the front end, like I said, dashboard, budgeting tools, stock market simulator, financial literacy hub, and AI in chatbot. And backend, Flask, MongoDB, authentication module, feedback processor, and integration layer where we have used which communicates with OpenAI and DeepSeek R1. So the evaluation and results, we had conducted a research of around 30 participants, which include students, professionals, and investors. So the results were that the financial literacy levels were for 55% for the beginners, intermediate were 35%, and advanced were 10%, which shows that more than 60% were new and had lack of knowledge in finance. So, and we had also conducted the research where the preferred learning tools was investment simulations like the market simulator was 44%, AI chatbot was 31%, and AI assisted quizzes was 25%. So our main AI chatbot and AI assisted quizzes sums up to around 56% of the participants. And the most challenging topics that they found were trading and investing, followed by budgeting and saving. And the engagement metrics post the use of the web was that 100% of users that had attempted at least one quiz and as well as interacted with the AI chatbot. And the quiz score improvement was 67% on average. It had got better from the initial number. I forgot to mention, but the initial number was around 42%. So to conclude, our research addresses the gap in youth targeted financial education using an AI powered learning platform. Users demonstrated significant improvement in financial understanding, confidence, and engagement. The system bridges the gap between theoretical learning and real world financial decision making. The intelligent AI agent framework integrates explainable AI simulations and chatbot interaction to create a dynamic learning environment. The use of error-based quizzes and real-time feedback led to better retention and critical thinking. So, like I said, there's a lot of there's lack of financial literacy in India. Our colleges, our schools specifically don't cover this topic. So there's an extreme need to do it, which was our thought of process at initial. Then the future work and scope is enhanced chatbot capabilities. Of course, to make it multimodal, predictive financial tools for future value and wealth forecasting, personalized learning experience, then gamified learning modules, and multilingual and inclusive access. Yeah, so these are the references. Thank you.
Thank you. It's a wonderful presentation. I have no question. Thank you. Over to
Okay.
you, Ashutosh.
Thank you, ma'am.
Thank you.
Now moving on to the next presenter. I would like to call again Ma'am Vanishri Pabalkar to present a paper on the title Application of Sentiment Analysis in the Marketing. Do we have you here with us, ma'am? Do we have anyone else from the team with us? Since there's no response, we'll be moving forward with the next presenter. I would like to call upon Ma'am Kumari Nidhi Lal to present a paper on the title Machine Learning Based Smart Recommendation System for Selection of Routing Protocol in Manets, as she was not able to present a paper in the previous session. Do we have you here with us, ma'am?
Thank you, Ashutosh sir, for giving me again opportunity. So I will share my screen.
Sure, ma'am.
I hope my screen is visible.
Yes, ma'am.
Okay. So good afternoon, all of you. I think it is a good evening. So good evening, all of you. My name is Dr. Kumar Nidilal. I'm working as an assistant professor in VNIT Nagpur. The title of the presentation for this conference is Machine Learning Based Smart Recommendation System for Selection of Routing Protocols in MANET. So we can see there are so many AI oriented and machine learning applications which is used to detect a particular disease, some image processing techniques, computer visions. But in the networking area, there is a lack of research and there is a research gap in the networking part. So that is the missing. So in order to do that, we have contributed that machine learning part in the networking. So that networking is nothing but the infrastructure that is known as the mobile ad hoc networks. As we know, this is the network which having no infrastructure. So any wireless device can contribute by making that network. So this device can be a hands-on device like your mobile phone, your laptop, or anything which is wireless in nature. Any routers or the towers can also be part of that. So these mobile ad hoc networks are basically the decentralized self-configuring networks where mobile nodes communicate without relying on the fixed infrastructure. And these networks are widely used in disaster recovery, military applications, regular communications, and some IoT applications also. So, however, due to their dynamic nature of the nodes, because nodes have free to move from one location to another location, Manet faces several challenges. What are the challenges? Challenges including when the frequent topology changes, when there is a limited bandwidth of the channel to transfer the data, whenever there is a high energy consumption of the battery, when you want to send the data that is sensed by the sensor, when we are talking about the IoT devices infrastructure using the Manet, and it is very prone to the unpredictable link failures. So there are various traditional routing protocols such as AODB, ad hoc on-demand distance vector routing protocol, dynamic source routing protocol, that is DSR, have been widely used, but they are basically struggle with their real-time adaptability in high mobility applications. So, in this area, there is very less literature reviews find out because most of the AI applications are related to prediction of the particular disease and some image filtering or some image analysis only. But when we are using some, you can say, the networking type of applications, like when we are going to transmit the data packet from one source to another packet, so what are the things we need, like we are using some fragmentation and the routing, and so many things we are needed for that. So there is a lack of contribution of AI in this area. So that is why there is a lot of survey paper exist that how can we apply the AI based machine learning or deep learning over the managed or some IoT environment, but the real implementation is missing over there. So that's why in order to implement our research, we have to start from the scratch only. So we are not taking any GitHub code, not any Kaggle code. We are to develop our own simulator that is used to implement the managed infrastructure. Now it is basically running and recommending the protocol, which is basically provided the useful information based on the features of the traffics going on. So the first traditional protocol is AODP protocol. In the AODP protocol is basically the reactive routing protocol it is, and it establishes routes only when a source node requires communication with a destination node, and it uses a route request packet. Two types of packet they have used. The first one is the route request packet, and the second one is the route reply packet. And these are the basically mechanism to discover the path in order to transmit the data and to minimize the overhead. And also AODB maintains sequence number. So as we know, what is the sequence number ranges from 0 to the power 32 minus 1, which is used to basically identify the particular packets and mitigate the route updates. The second one is DSR, Dynamic Source Routing Protocol. It is basically a source-based routing protocol in which entire route to the destination is stored in the packet headers. Because the route is stored in the packet headers, so we can say there is an overhead in the packet transmission itself when we want to basically find out the route, because the first the route is established, and once the route is established only we can transfer the data, so it is prone to higher overhead. AODB basically is a table oriented approach, but DSR is a dynamic approach, but again there is a overhead over. So in order to improve that, some times table AODB is proposed that prioritize link stability while scaling, selecting the routes. And unlike the traditional AODB that selects the shortest path without considering the link durability, this TS AODB incorporates a stability metric to estimate the expected lifetime of the links. So in this way, it can reduce the route failures as well as frequency of the route discovery. Now the smart DSR, this is the last one of the literature survey. That is, smart DSR is basically the something, two key features they have to use, like the mobility aware routing. They have some pattern that at which time a particular node is transferring from one location to another location. So some data analytics part is also there over there, like mobility aware routing it is. And the second one is it is very adaptive to the route selection, because we they are using the mobility as a feature. So based on the mobility pattern, they have to basically proceeds towards the route selection. In this way, they have improved the packet drop ratio over 20% as compared to the previously traditional DSR protocol. So motivation for the AI based routing, as we say that mobile ad hoc networks are very dynamic in nature, and they have to select the optimal routing protocol is very crucial for maintaining the data transmission. So in the machine learning techniques, particularly we have implemented logistic regression, and it can be utilized to analyze the network performance data and recommend the best routing protocol based on the real-time condition. So what are the real-time conditions we have taken? You can see there are three bullet points. The first one is node mobility patterns we have analysis. Second one is the link quality fluctuations. And the third one is the energy consumption trends. So based on these factors, we have analysis the pattern. And based on that patterns, basically AI-based routing recommend one protocol among of AODB, DSR, Smart DSR, and TS AODB. So according to the networking infrastructure, stability of the link, number of nodes, and so many things, our protocol will be switched from one to another. So this is a research objective and the contribution. So our first research objective is to analyze the limitation of the traditional protocols, which is already done. And this study contributes to the growing body of the research that seek to the integrate AI into the core network. And because we are integrating AI into the network, so we have to generate the data set in a very large manner. So we have run the simulation 1000, 2000 times to analysis some features and patterns inside the features. So for the decentralized environment, whenever there is a location change, so it is very tough. But somehow we have done by using this intelligent and self-optimizing mobile networks. So what we use basically machine learning we have to use to make the smart decision, and we have to train the models on the past routing data to predict the optimal paths. How the machine learning helps, it remembers the past routes to find the best ways and quickly changes the paths when the network changes. Avoid slow or broken connections for the faster data. So it is very adaptive to the link longevity as well as link stability. So in the right hand side, in the left hand side, we can see we are starting the simulation for number of nodes are 2, and we are increment the number of 2 to from 2 to exactly 2000 nodes. So we have implemented the simulation to up to 2000 nodes. So it is only basic example for understanding, because if we jump over the 2000 nodes, it's not ready to you can say understand very easily. So coordinates we have assigned, as well as whenever the coordinates are nearby to each other, then only the data will be transmitted. Otherwise, not. So we can see in the left hand side, there's a performance score for each of the AODV routing protocol. Performance score is basically telling so many matrices. These matrices are named as, you can say, the discovery time, end-to-end delay, retransmissions, number of hops, and the number of nodes in the network. So based on that, we have calculated the performance score, and
This is a
calculates
gentle
the
reminder
performance score, and
that 9 minutes.
AODV routing protocol is recommended. Yes.
This is a gentle reminder that 9 minutes have been completed.
Okay. So first we have to read the historical data, then we have to choose the nearest node count, then we have to calculate the performance score, and we have to select the best protocols. And then the recommendation will be taken place. So the first logistic regression is performed, because logistic regression is used for the classification, and we have four traditional protocols over there, and we have to choose among of four and switch to one protocol to another protocol. That's why we have choose the basic one, logistic regression. We have also tested our simulation to SVM, KNN also, as well as we are going towards a deep neural network. Results are also very good, but the thing is, for this paper, we have provide the results only for the logistic regression. So we can say for the previous accuracies was 0.80. When we trained our data again for the more, you can say, dynamicity and mobility in the network, the current accuracy will get reduced to that. That is 0.70. So we can say when there is a node mobility is high, the accuracy will be, you can say, shift to lower side.
Ma'am, you have exceeded the 10-minute time limit. Kindly conclude the presentation.
Okay, so just give me 2 minutes then.
Sure, ma'am.
Okay. So in the right hand side, you can see the data set we have simulated. These are the simulation parameters, and these are the results. We can say the end-to-end delay. The last one, dotted one, that is denoted by the pink one, is ML recommended model. We can see the end-to-end delay is very small for the number of nodes we have plotted for the 120. For the discovery time, we can also see the discovery time, which is recommended by the ML recommended protocol, is very taking less time for discovery of the content, as well as whenever there's a packet drop ratio and we have to retransmission count. So we can say when we use ML recommended, our retransmission is very minimum as compared to the another traditional scenarios. These are the number of hope counts when we are going to transfer the data. So when we are using ML recommended, we have used the protocol used very less number of hope counts to transfer the data. So these are the conclusion. The recent advances are very adaptive to the MANET environment, and these capabilities are very crucial and unpredictable to the time-sensitive nature of the MANET. And for the future disco, we are going to implement some LSTM model over there, because we are focusing over the continuous data and more recognizing pattern, because we can see the mobility, when there is a large mobility, the accuracy is getting lower side. So we have to reduce that limitation in our work. So these are the references we have taken for our base paper. Thank you.
Thank you for this meticulous presentation. I have no question. Over to you, Ashutosh, as you have already explained everything. Thank you.
Thank you, ma'am. I sincerely thank our authors for the excellent presentation and contribution in this session, and all the participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for your support during this 10th version and all the previous 9 versions of the conference. We'll be happy to have you in the 11th version in 2026. All the presenters will be getting their digital certificates through email within 2 working days. Further, all the papers have already been forwarded to the Springer. The publication will be live within 7 to 8 months. Kindly cooperate with the team of ICT4SD 2025. I also thank the session chair, Dr. Garima Sharma, for chairing this session. I would now like to request ma'am to share her thoughts and feedback about the presentation of the session.
Thank you, Ashutosh. As we conclude this enriching session, I first want to express my sincere appreciation to ICT for entrusting me with this important role. It's been honor and pleasure to chair today's discussions. I would like to extend my heartfelt congratulations to all the authors and presenters for sharing such innovative, socially relevant, and technically advanced work. From the application of deep learning in medical diagnosis and sentiment analysis and marketing to energy optimization and AI enhanced education, each presentation today showcased how technology can be catalyst for sustainable development and better societal outcomes. I also thank the conference organizers and technical team for enabling a smooth virtual session. It's been a pleasure to serve as a session chair and witness such a high caliber of research. Wishing all participants continued success in their academic and professional journeys. Thank you once again.
Thank you, ma'am. On behalf of a token of appreciation on behalf of ICT4SD 2025 and Global Knowledge Research Foundation and partners. Thank you everyone for your valuable presence. Just before we end the session, I kindly request you all to switch on the camera for a quick snapshot of the virtual conference. Thank you everyone.
Thank
Stay
you.
safe,
Thank
take
you,
care.
everyone. Thank you.